everyone, Greg here, and so now we made it to 1,024 subscribers, and I'm so delighted, and thank you very much to everybody who did subscribe. And because I am not very quick in making those videos, we are now at 1,253 subscribers at the moment of recording, and that's just amazing. Awesome. Thank you very much to everybody who did subscribe, and if you haven't subscribed now, why not? Okay, so this is a subscriber special, and you know, if you've been here a while, you know what we're doing on those subscriber specials. We are working on the duCx programming language. So the duCx programming language was a fun, kind of educational, kind of a goofy language I created for the sake of the subscriber specials. So in episode 1, duCx could barely run more than hello world. In episode 2, it was quite a big step up, because then it became Turing complete, and that is when we computed a couple of factorials. We added the while loop, we added the declaration of variables, we added the parsing of mathematical expressions. And now in episode 3, this is a big step up again, and we have quite a number of features, and I'm going to show them on the screen here, all the different features. And I think most noteworthy is that we can write custom functions. There's a proper stack implemented. Quite a number of features have been added, but for me it was never about the features in the first place. I always came at it from the perspective of what can the language do. Okay, so hello world number 1, factorials number 2. In episode 3, what would I write in the duCx programming language itself? What would I make the language do? And so I decided that the interesting thing to do was to make it draw a Sierpinski triangle in an interesting way. So what is the Sierpinski triangle? Well, imagine you take an equilateral triangle, you find the midpoint of each of the sides, and then you connect them and you cut out the triangle in the middle. Now you have 3 smaller triangles. Rinse and repeat infinitely many times, and you end up with this. One of the very early videos I made on this channel was about recursion, and basically I explained how to draw one of those triangles. Alright, but I was talking about drawing the Sierpinski triangle in an interesting way. So how do you do that? Well, you start with the Pascal's triangle. What is that? Well, you have ones on either side, and then the numbers in the center are the sum of the 2 numbers on top to the left and the right. So here now you would have a 2, there you'd have a 3, another 3, and so on and so forth. Now, this Pascal's triangle has a lot of very interesting mathematical properties, but one of them that I like very much is that if you color all the even numbers red, guess then what you end up with? You end up with the Sierpinski triangle. Okay, so now how do you mathematically, and not so much mathematically, but how do you programmatically compute this triangle? Well, the obvious answer would be to use arrays, and you know, to have one array for every row of the triangle. But the thing is, duCx doesn't support arrays yet. So how can we do this? There's another way of computing the numbers, and that is with combinations. Now, I don't want to get too deep into combinations and make this into too much of a mathematical video. One of the very first videos I made on this channel, even before I was taking YouTube very seriously, and also when I wasn't very good at making videos, I made one about probability where I explained combinations and permutations. So I'm just going to skim over that. It's not really essential to understand the video overall. Just understand that you can compute Pascal's triangle with combinations, that the formula looks something like this. And of course, the formula involves factorials, and factorials is something that we discussed and computed in the previous episode. So we can just use that and basically build on top of that. So I think that this is like an interesting program to kind of gradually extend the abilities of the duCx programming language. So here's the actual duCx code that will draw the Sierpinski triangle. So you see how we have the function factorial, we have the function combination, and of course that's the big change in this edition of duCx, is that now we can write those functions. Like before we had more like one instruction after the other, but now here we have proper functions. So the combination, we're using factorials, of course, to compute those combinations. And then here in the main, we clear the screen. We have this main loop, and this computes one row at a time. Okay, you see the /n there, that's the new line. And then, so this will compute a row, and you see the combination here gets called. Now, what we have here, those are escape sequences, which basically set up the colors for the Linux terminal, and whether we have an even number or an odd number, we have different colors that we want to display. And so these are just blocks that will be displayed in a specific color. So now if I actually run, this code, then you see this is our Sierpinski triangle. Okay. Also, while we're here, let me show off the new feature where you can add a command line option, and this will give you the version of duCx. And look at this, is it not flashy? So now you can easily look up which version of duCx you're working with. All right, so usually around now, what I would do is I would discuss the code and explain how I did what I just did. And it seems that people are usually not really watching those and not really interested in that. So what I'm going to say this time is, as usual, the code is available on GitLab. If you want to analyze the code, if you want to see how I did that, I have the code up there, but I'm not going to discuss the code this time. What I'm going to do instead is I'm going to talk about some of the features of duCx, some of which are already in the language and some of which I plan to put in there in the future. So one of them is forced initialization after declaration. So I think that's a very useful feature. You should always initialize your variables. And I've had bugs. I've actually personally encountered bugs where I forgot to initialize a variable and that led to a bug. So I think there's definitely wisdom there in saying you should always initialize a variable. Every keyword will have just one meaning, okay? One role for every keyword, unlike the keyword static in C. So what does static mean in C? It can mean that the value of a variable should persist after multiple calls of a function, or it can mean that a certain function should only be available and callable from within a translation unit. So there's that ambiguity in the word, and that only makes the parsing more difficult, because once you see the word, then you also have to derive from context what it means this time, and so that's not a good thing. So each keyword just one role, okay? Just to make things simpler. I don't want to have the bool data type in the language. Now the reason for that is because the smallest addressable part of, well, the smallest addressable memory in a computer is basically a byte. And so why have a bool that is supposedly just 1 bit when that's a bit deceptive, since you can't have any less than a byte as a data type. So I don't want the bool data type. I don't like the fact that it's in C, and I think it shouldn't have been in there. Go-to statements. I don't want to have go-to statements. And the thing is, when I was learning to code, I was always told go-to statements are bad. What I've since learned is that the evidence for this is not very strong, to say the least. So I kind of softened my stance on that a little bit. I don't think it's necessarily bad if you know what you're doing, if you're using go-to statements. I don't want them in duCx. I don't want them in my language. And I think it's probably a better language for it, especially if it's eventually going to be used for applications. And so no go-to statements. Also, no global variables. Now, we'll see how well that's going to work, especially if I want to maintain compatibility with C. And in C, you have some of the API kind of forces you to use global variables like error number and stuff like that. So I think it's just generally better practice if you don't use them. Okay, in terms of what I would like to do in future versions of duCx, currently every variable starts with a $sign. You know, I thought that was a good idea at the time, and I'm starting to think, okay, probably doesn't make the parsing that much easier. I don't think it really offers that much of an advantage, and it is really awkward to type all the time, so I'd rather it not be there. So I believe in future versions of duCx, variables are not going to start with a $sign. Also, single equal signs in a condition. So if you have an if statement and you have a double equal sign, that means basically a comparison. If you have a single equal sign, that means an assignment. In theory, you could use an equal sign, a single equal sign inside a condition. In C, at least you can do that. In ducks, I don't think that actually currently works, now that I think about it, but I think I'm going to explicitly ban this. Okay, now then when it comes to switch statements, the way switch statements in C are often heavily criticized because of the break statement you have to put in there, and if you don't put a break, then it falls true. And I can see why people complain about that. I think there is something elegant about it, right? I mean, I have this code in my library where the code for figuring out the number of days in the month, and if you look at that code, you know, I think that there's a very good reason there for deliberately falling through. And what should I have done there? I mean, you know, write the same thing or similar thing 12 times. I mean, that doesn't seem very reasonable. No, I think that's a very good use of deliberately falling through the cases of a switch statement. So my idea is, what if we have a fall statement that we deliberately fall through, that we basically, by default, there is a break, an implicit break. You don't write it. You just stay within a specific case unless you explicitly say you want to fall through. That's probably better, and it's probably leading to fewer bugs and problems. So I'm going to experiment with that, and I think in future versions of ducks, when I eventually implement the switch, I'm going to have a fall statement instead of a break statement. Another thing is, what about the curly brackets? Now, the curly brackets, you have them around the function, and then you have it inside the function for if and the while and so on. Now, what if you mess up the curly brackets and there's a mismatch in the nesting of the curly braces? Then you end up with you end up with problems, and you basically end up with a parsing error. Well, what I had recently is I wrote this bug in my code where I had an if statement. There was a single line if statement, so I wrote the opening curly brace by mistake, and then I didn't write the closing one. But the thing is, the error I got by GCC, it was like pointing to the very bottom of the file, because basically GCC couldn't pinpoint where the error was, and so it just produced the error when it had parsed the whole file and it got to the bottom. So what I'm suggesting is, in future versions of ducks, I'm going to put an additional symbol, like maybe an asterisk, behind the closing curly brace of the function. Okay? And so the consequence of that would be that the curly braces have to match, but you need a curly brace plus an asterisk to match the opening curly brace of the function. And so what that would do is that if you mismatch the curly braces and there's a parsing error, you can at least pin it down to the specific function. Let's say you forget an open curly brace somewhere. Once you encounter that closing curly brace, you can at least say, okay, that should belong to the function. So therefore the mismatch in the nesting is somewhere within that function. And I think that probably would be much better and more convenient. Okay, and then finally, once we finally gonna implement arrays and pointers, I think I'm gonna implement boundary checks for arrays and boundary checks for pointers, so that the pointers can't go outside a particular area of memory, and this will protect against buffer overflows and various bugs and segmentation faults and things like that. So that's the plan for the future versions of ducks. I think they're good features, and let me know in the comments if you agree with that or if you think I should do something else. Okay, so one thing I will say is that ducks will never be an object-oriented language, so there's no point in suggesting features like encapsulation or inheritance. I am not going in that direction. This is not the direction that ducks is taking, and if you wonder why, this will probably be the subject of an in-depth video at some point in the future. But for now, all I'm gonna say is I do not approve of the object-oriented paradigm, and this is not the direction I'm going into. Okay, so this is it. Thanks for watching. Thanks again for subscribing. And I have many ideas lined up for new videos. I don't know when I'll get to them, but please keep subscribing, commenting, sharing the videos. It really helps me in the algorithm. And I'll be back with another one, hopefully quite soon. Bye.